In these questions, we're going to be solving trig equations between different domains. So first of all, in this example, I have tan of x is equal to 2.14, where x is between 0 degrees and 720 degrees. Putting this onto a unit circle, we're going to, because we know that tan x is positive, we know that we're in quadrant 1, the all quadrant, and quadrant 3, the tan quadrant. And because we're going from 0 to 720, we're going to go all the way around once to 360 degrees, and then all the way around again to 720 degrees. So we end up with 4 solutions because we've gone around 2 times. We find the principal solution, that is the first solution, by doing tan inverse of 2.14, which gives us 65 degrees. So that is our first solution. Once we know that, we're going to use the unit circle, and each time the acute angle is 65 degrees. So we have 180 degrees plus 65 to get to this one. And then we have 360 plus 65. And then we have all the way around again. We could either do 540 plus 65 or just add on 365 as we go round an extra time. So let's now look at sine of x equals 0.65 in the domain from minus 360 to 360 degrees. First of all, let's think about how many solutions there are. Sine of x is positive in quadrant 1 and quadrant 3. So we're looking for this angle here. How many times are we going to go round? Well, we're going to go from minus 360 to 360. That is, we're going to go from 0 round this way to 360, which is going to give us 2 solutions. But we're also going to go from 0 backwards by 360 back this way, which is going to give us another 2 solutions. So we're looking for 4 solutions in total. First of all, we're going to find our principal angle, x1, which is equal to sine inverse of 0.65. When we put that into our calculator, we get 40.5 degrees. Now we're going to find all our solutions. So the first solution is that 40.5 degrees. Our second solution, I'm going to go for the second green solution, is going to be 180 minus that 40.5. So 180 minus 40.5 gives me 100. Let's write it down. 180 minus 40.5 is equal to 139.5 degrees. My third angle is going to be the blue one working backwards. My first one is going all the way back to minus 180 and then minus another 40.5. So minus 180 minus 40.5 gives me minus 220.5. And finally, x4 is going to be going nearly all the way back to minus 360. It's going to be minus 360 plus the 40.5. Which gives me an answer of minus 319.5 degrees. And I should put degree symbols on all of these because we're in degrees. Continuing now, cos of x is equal to minus 0.1 between 0 and 4 pi. So first of all, I am now in radians, so I'm going to change my calculator into radians mode. And then let's think about where we are. Cos of x is negative in quadrants 2 and 3. So we are here. And we're going from 0 to 4 pi, so that is 2 complete cycles. So 1 cycle and 2 complete cycles. So I have 4 solutions I'm going to find. My first solution is going to come from cos inverse of minus 0.1. I'm going to type that into my calculator. And I get an answer of 1.67 radians. Now that is actually going to be, that 1.67 is this angle here. Not the acute angle, it's the obtuse angle. If I wanted to find the acute angle in here, I'm going to need to do pi minus that. So I'm going to do that now. I'm going to do pi minus that answer, and I get that this angle here is 1.47. So now I can start working out all my angles. x1 is 1.67. x2 is going to be pi plus that acute angle, the 1.47. I'm going to add pi onto my acute angle, and I get 4.61. Next, I'm going to go all the way around to get to the next one, which is going to be 2 pi plus that blue angle would work. So x3 will be 2 pi plus the blue angle, which is 1.67. I can do that. 2 pi plus 1.67 gives me 7.95. And x4 is going to be, well, I could do from here 3 pi plus the purple angle, or I could do 4 pi minus the 1.67. I'm going to do that one, 4 pi minus the 1.67, which gives me an answer of 10.90 or 10.9. And there I've got my 4 solutions for this particular equation. Looking at the next one, sine of x is equal to 0.9 between minus 180 degrees and 180 degrees. I'm back into degrees, so I'm going to convert my calculator back into degrees mode first of all. And then I'm going to think about where are my answers. Sine of x is positive in quadrants 1 and 2. And then I'm going from 0 forwards to 180. So I'm going that way, which gives me 2 solutions. And I'm going from 0 backwards by 180, like that, which gives me no further solutions. So there are only actually going to be 2 solutions here. I'm going to find my first solution doing sine inverse of 0.9, which gives me 64.2 degrees. And then, so my first solution is 64.2 degrees. My second solution is going to be, well, that 64.2 is this acute angle here, so I need to do 180 minus 64.2. 180 minus the 64.2 gives me 115.8 degrees. And on to the next question. Tan of x is equal to minus 0.75 between 0 and 540. In my unit circle, tan is negative in quadrants 2 and 4. And I'm going from 0 to 540. So I'm going 0 to 180, to 360, and then another 180 will get me to the 540. So I'm doing 1.5 full cycles here. This time I have 3 solutions that I'm looking for. To find the first one, I'm going to do tan inverse of minus 0.75, which gives me an answer of minus 36.9 degrees. That's not actually one of the answers in what I need. That's telling me that this angle here is 36.9 degrees, but minus 36.9 is not in my domain. So now I'm going to have to work out all of them from there. The first one is going to be 180 minus the 36.9. which gives me 143.1. The second one is going all the way around to 360 minus the 36.9, which is 323.1 degrees. And finally, the third one is going all the way to the 540 and taking away the 36.9, which gives me 503.1 degrees. On to the next question. Cos of x is equal to 0.3. Where is cos positive? It is in quadrants 1 and 4. And we're going between minus 720 and 360. So first of all, let's do the positive bit. From 0 round to 360, going that way round, there are two solutions. And then going backwards to minus 720, going to go all the way around to minus 360, and then all the way around again to minus 720. So I've then got 1, 2, 3, 4 more solutions. That is 6 solutions in total. I'm going to find my first solution by doing cos inverse of 0.3, making sure that I'm in degrees. Gives me 72.5 degrees. That is in my domain. So my first solution is 72.5. My second solution is going to be, the other green one is going to be all the way around to 360 and then take away the 72.5, which gives me 287.5 degrees. And then to find the other 4, I could keep going backwards and find them, but actually another nice thing about these trig functions is they repeat every 360 degrees. So actually I can just take 360 off of each of these. So I can find the third one by doing 360, sorry, doing 72.5, take away 360. That gives me minus 287.5. I can take off another 360, and that will give me another solution, which is minus 647.5. And then I can do the same, but starting at the 287. So 287.5, take away 360, gives me minus 72.5, which is that first one on the blue ones. And then taking away 360 again, I get minus 400. Running into the next one a little bit. X6 is minus 432.5. These are all degrees, so I should of course have degree symbols on all of these to show that they're not radians. Sine of x equals minus 0.85. In our unit circle, minus 0.85, sine is negative in quadrants 3 and 4. And then I'm going between unusual degrees here, between 100 and 800. So 100 degrees is about here. So I'm going to start about here, just a little bit after 90. And I'm going to go round and to 360. That one's going to be to 540. If I go all the way around again, I'm going to get to 720 to get to this point here. And then I need 80 more to get to 800. So 800 is going to be somewhere up here. So this angle here was the 100 degrees. This angle here is the 800 degrees. So if we look at that, how many times am I crossing the things here? I've got 1, 2, 3, 4 values that I'm looking to find. X1 is going to be sine inverse of minus 0.85. which is equal to sine inverse of minus 0.85 is minus 58.2 degrees. So actually that's going into quadrant 4 but going backwards, which is not what I want, but what that is telling me is that this acute angle here is 58.2. So now I can find my first solution, which is going to be 180 plus the 58.2, which is 238.2 degrees. My second one is going to be 360 minus the 58.2, all the way around to 360, and then go back by 58.2, which gives me 301.8. And then to find x3 and x4, x3 is just going to be 360 more than this one, so 238.2 plus 360 is 598.2, and x4 is equal to the 301.8 plus 360, which is 661.8 degrees. And if we added another 360 onto either of those, we'd go beyond the 800, so that's all of our possible solutions. And finally, tan of x equals minus 0.4, whereas tan negative in quadrants 2 and 4. And we are in radians, so make sure we set ourselves into radians. And between minus 3 pi and pi, so pi is going half a cycle this way, and minus 3 pi is going back pi, back 2 pi, back 3 pi, which gives us 1, 2, 3, 4 solutions in total. x1 is equal to tan inverse of minus 0.4, which is minus 0.381, which means this angle here in radians is 0.381. And that's actually in our domain because we wanted to go backwards. So we can write that as our first solution this time. x1 is equal to minus 0.381. And the really nice thing about tan is we can just add pi in either direction. So we need to, that's the first one here, we need to add pi to get that green one. So if we do minus 0.381 plus pi, we will get to that green one. Add pi onto our answer. We get 2.76. To go backwards, we could start at minus 0.381 and take away pi as well, which gives us minus 3.522 or 3.52, and then we can take away another pi to get our final answer, which is minus 6.66. It's not as immediately obvious if that is within our domain of minus 3 pi to pi, as it was with degrees. But because we use the unit circle to determine those were the 4 angles, we know that that is indeed going to be our fourth solution.